Okay, welcome to the fourth video on factoring. This one's going to talk about the difference of squares pattern and factoring by grouping. Okay, first of all, difference of squares is used when we have just two terms. Trinomial factoring is used when we have three terms, but some cases we can factor. This one on the left, it's possible to factor that into smaller pieces because this has a negative sign here, a subtraction. This one on the right, we can't really do anything with that, with the plus sign, so we won't be able to do anything with this one. But on this left side, we're going to learn a procedure that will let us break that down further. It's called the difference of squares pattern. To see the way it works, let's work backwards from an answer for one of these problems. Let's say I have this particular kind of special pair of factors here, x plus 2 times x minus 2. And what makes this special is that it's the exact same things, x's and then 2's. The only difference is one's plus and one's minus. What happens if I multiply those together? So everything in here multiplied by x is x squared minus 2x. And then everything in there multiplied by the 2 is 2x minus 4. 2 times negative 2. And when I combine like terms, the negative 2x and the positive 2x, because everything was symmetrical here, they cancel out, leaving x squared minus 4, something with just two terms. Okay, so that's kind of a special situation. X squared minus 4 is the same as x plus 2 times x minus 2. Okay? So if we could just, they're kind of special factors because they're symmetrical, because the left thing was x and the right thing was 2. And that means that if we could just remember that whenever we have x squared minus 4, we know automatically it just, by the pattern that we've memorized, becomes an x plus 2 times an x minus 2. So we're going to do that, except that we're going to not only use this pattern for x squared and 4, we're going to use it for things in general. So instead of using x's and 2's and some specific things, let me just make a generic thing. I'm going to call the thing on the left, the number on the left a, or maybe it's variables, and then b for the other things. So let's just do the same kind of multiplication. If I take everything here times a, that's a times a, which is a squared. And then let's say a positive a times a negative b is a negative a times b. And then everything here times the b is a positive ab. And then a positive b times a negative b is negative b squared. But because these are identical, one's positive, one's negative, they cancel, and I get a squared minus b squared. And so what that means is, whenever I have anything of the form something squared minus something else squared, then you can write it in terms of the left item plus the right item times the factor left item minus the right item. Okay, so we just say a squared minus b squared can immediately be factored by its pattern into a plus b times a minus b. Okay, and this is called a difference of squares because it's a difference of two things that are squared. Okay, let's see how we would use it in practice. Let's say we have x squared minus 4 again. Here's the way I do it. I like to go ahead and say, well, that x squared term, if I can think of it as something being squared, and the right term as something being squared, that the 4 is a 2 squared, and there's a subtraction sign in between, then that means that this thing right here, this x is the a. This x right here is the a, and this 2 right here is the b. And so that means that I know by pattern that whenever I have a squared minus b squared, I can write it as a plus b times a minus b. It means that I can write this as whatever a is, which in this case is x, plus whatever the b is, which is 2 in this case, times the a, which is x here, minus the b by pattern. So it's x plus 2 times x minus 2. I'm not going to do checking in this section, just to get a little bit more in so we can fit under the time limit for these videos. Okay, let's do this one, a little bit more complicated, but there's a subtraction sign, there's two terms, so it seems like I should be able to do difference of squares. What I'm going to do is think of the left thing as 2x being squared to produce a 4x, and the right is a 3y being squared. And that means that my a is 2x, and my b is 3y. And that means that the a plus b is just 2x plus 3y, and the a minus b is 2x minus 3y. So I can just identify what the x is and what the y is, and then just take the thing from the inside of the parentheses plus the thing on the right from the parentheses on the right times a factor with the thing on the left minus the thing on the right. That's all there is to it. Let's do another one. See if you can do this one. We'll pause, unpause it when you're ready. Okay, to me this is an x being squared and an 8y being squared. And that means the a is x and the b is 8y. And that means I can have x plus 8y times x minus 8y. Okay. One more, even more complicated. This one's a little tricky because 8 is not something that I can take a perfect square root of, right? And also the x cubed. You know what, though? I think I can use my greatest common factoring here. I could make that 8 into a 4, which does have a perfect square, by factoring out a 2. And I could take that x squared, or x cubed, and I could factor out one of those x's. And what would I get? I would get 4 left and an x squared. And then to take the 2 and turn it into a negative 32, I'd have to multiply by a negative 16. I've removed the x, and I have a y squared and a z squared. All right, so I can do greatest common factoring first, and then keep that off on the side. And then let me write this as, this is a 2x being squared, and this is a 4yz being squared. This is, inside here, an a squared minus b squared pattern, right? And that means that, I'm going to copy my greatest common factor out there, that I can write this part as a plus b times a minus b. So you can get some very complicated expressions to break apart. Sometimes, though, you have to factor out a greatest common factor to get something like 4 or x squared or 16, which does have a perfect square. Okay. One more example. Could I do greatest common factoring here? Definitely could take a 3 out, and that would be left x squared minus 4, and that's an x being squared and a 2 being squared. So using the pattern, it's x plus 2 times x minus 2, and whatever we have from that is multiplied by 3. All right. Okay, so that, one more example, x squared plus 9. Now you might be tempted to say, okay, this is x squared plus 3 squared, and say that this is x plus 3 times x minus 3. But the problem is, that's wrong. And the reason why is this pattern only works if this is a subtraction sign. Since that's addition, we can't factor. In fact, x squared plus 9 is already factored as much as we can factor. So don't make the mistake of using this technique when there's a positive there. It's got to be a subtraction. All right, that's difference of squares. The last factoring technique we're going to talk about is factoring by grouping. And this is a special situation that is used when we have 4 terms. Okay? So let's say we have something like this. We have 3x cubed plus x squared plus 15x plus 5. There's kind of a step-by-step procedure, so I'll just talk about the whole procedure here for this one example. The first thing you want to do is you want to split the 4 terms into 2 groups that each contain 2 terms, just by putting parentheses around them. So what I could do is I could take the left group, 3x cubed, I could just take the first 2 terms and just group them together by putting a parentheses around that. And then I say plus, and then I put a parentheses around the remaining groups. And I force this to be a plus. Even if this was a minus 15, I would move the minus inside with the 15. All right, so the first step is just to separate them into 2 groups of 2. All right, and that's already done here. The second step for factoring by grouping is to, within each term, or within each group, factor out the greatest common factor. So on the left side, I could take an x squared out, and I'd be left with a 3x plus 1. And on the right side, I could take a 5 out, and I'd be left with a 3x plus 1. All right. So you factor out the greatest common factor from each group independently. Now, at this point, if the 2 things in the parentheses are identical, you can carry this procedure farther. Sometimes they're not identical, and if that's true, then it just means that factoring by grouping won't work in this case. But if you do happen to have that, then you can factor one more step. Let me show you over here on the side what I'm going to do. If I had this, x squared times b plus 5 times b, hopefully you agree that I could factor the b out as a greatest common factor, and I'd be left with x squared plus 5, right? So all I'm going to do is the same thing, except that the b that I'm going to factor out, it's the whole thing in the parentheses. So I'm going to be factoring out the thing in the parentheses onto the side, 3x plus 1. And what I'm left with is x squared plus the 5. And so that's how this factors by grouping. So you can take something that's 4 separate terms and write it as a product of 2 binomials. That's called factoring by grouping. You should always check your answer in this case too, so let's see if that is true. Everything in here times 3x would be 3x cubed, plus 5 times 3 is 15x's, and then everything in here times 1, so x squared plus 5. Let me just reorder them there. I have the x cubed term first, then the x squared term, then the x term, and then the number term, and that is the original expression, so that is the answer. Okay, a couple more quick examples here. Try to pause the video and see if you can do this by grouping. It doesn't really matter what order we're in. I can go ahead and factor. Let me just start by grouping the left group separate from the right group. Then we're going to factor out what we can in common. Let's see, on the left side, what do I have? I really can't factor anything there, so I'm just going to have a 1 there, I think. But over here, I think I could take out an x squared, right? And I would be left with 5 minus x. And because those two things are identical, I can factor those over onto the side. So I have 5 minus x times 1 plus x squared. Let's check. In this case, we should check, I think. These kind of problems, it's easy to make a little error. So everything in here times 5, 5 plus 5x squared, everything in here times negative x. Negative x minus x cubed. Let's see, I've got a 5, a negative x, a 5x squared, a negative x cubed. That works. Okay, one last example. Group. Now for this one, I'm going to put a plus and include that negative with the 3x inside the parentheses like that. On the left side, I could take out an x squared, and on the right, I could take out the negative 3, giving me x plus 1. Okay. Wow, in this case, the two things don't match, and that means that this doesn't work. Sometimes factoring by grouping doesn't work. And in that case, then your answer is the original. There's nothing else to be done. If I can't take out a greatest common factor, and I can't factor by grouping, then I just have to leave it like that. Okay, one more example. X cubed minus 2x squared. We'll group that and we'll do this. Let's factor on the left an x squared out. And on the right, we'll take a negative 3 out. If I take a negative 3 out, that's got to become a negative 3. So negative 3 times negative 2 gives me the positive 6. Those do match, so I can factor that out, leaving x squared minus 3. All right, there's the answer. All right. Summary of factoring. We've had 4 videos on this. Just to kind of quickly put it together, there's 4 techniques. They're used in different situations. You can factor out the greatest common factor, useful for all expressions. Not always is there a greatest common factor, but you should check for that in every case. If you have trinomial factoring, you do one of the things in videos 2 or 3 for 3 terms. If you have 2 terms, you can use the difference of squares pattern we talked about in this video. And if you have 4 terms, you can try factoring by grouping. Okay, we might have another minute left on this video. I just want to go back to this problem really quickly. Trick question, is this fully factored yet? Actually, it isn't. And the reason why is you can factor this term further, because this can be written as x squared minus the square root of 3 squared. So it is actually possible to factor this further. You have x minus 2, and then you have a plus b times a minus b. This is actually fully factored, but depending on your class and your teacher, we might want you to stop at this level. But for especially advanced students, you may want to know that it is possible to take that right term, because it's a difference of squares, even though you have to get to a square root. It is possible to factor further. All right, that concludes the summary of factoring. Thank you very much.